Okay, so I want to spend a couple of minutes talking about the empty property or empty set property. So we know from the last lecture that an empty set, right, contains no elements. Right. And I like to start off by just reviewing a little bit. So look at some true or false questions. First example, I have, let's take this back. I forgot I can erase. Okay, so first example here, I have, how about this element 2? I say 2 is an element of this set. So is this true or false? Once again, is 2 an element of this set? We see this to be true because once again, 2 is in that set. All right, how about our next example, B, which tells us that 5 is an element of this set. Is that true or false? All right, so is 5 an element of this set? We should see that this is false once again because 5 is not in there. All right, continuing on. Let's take a look at this next example. So now we're talking about subsets, right? Subsets. All right, so this is saying, is this a subset of that set? And once again, in order for them to be subsets, both of these elements must be found in there. And we see that to be the case. So we can say that this is true. And as we saw in our previous lecture, what if we flip these the other way around? Right? Is this set a subset of the following set? Once again, in order for it to be a subset, all of these must be in there. And we see that 1 and 2 are, but we see that 3 is not in there. Therefore, this is false. So I think these are some great examples because it reviews what we covered last time. Once again, really understanding that these first 2 examples are in regards of elements of, right? And these next 2 examples is in regards of subsets. So really wanting to look at example B and example D, right? Because this subset, right, we can clearly say that this is not a subset because you can tell me that 3 is not in there. And that's very important to understand, right? When it comes to working with subsets, if you can tell me that a specific element is not in the other set, it's not a subset. So if the element can be specified, sorry about that, then it's not a subset. once again, we have A, B, C. And this is a true or false question. Is this a subset of A, B? All right, so is this a subset of that set? All right, this would be false. Why? Because C is not in that set. So I want us to not forget that as we talk about the property of an subset and the empty set. So a very important property, this tells us that an empty set is always a subset of any set. All right? An empty set, think about it. Empty set is always a subset of any set. So this is telling us that an empty set is always a subset of any set. We can call it A if we want. All right, where A refers to any set. Why is that the case? All right, because going back, thinking about what we did here, if you can tell me that this element is not in there, then it can make it a false statement. We could say it's not a subset. So take a look at an example. All right, once again, 1, 2, 3. Is this a subset of 1, 2? All right, this is false because 3 is not in there. All right, so now what about this? Is an empty set a subset of 1, 2? Well, we know that an empty set can be seen just like this. All right, and in order for it to be false, you can clearly say, hey, this element is not in there. But this has no elements. So you can't say that, you can't give me a specific element to say it's not in this set because there is no element in there. And our property tells us that an empty set is always a subset of any set. So this is true. All right, so a nice example of really understanding the terms that we've looked at so far: element, subset, empty set. Thank you.